Hi, Algebra 2. This is a video of the homework answers for Lesson 10. We're learning about the tangent function. So you should have tried these problems already, and these are just the solutions to them. Remember when we did tangent back in geometry, tangent was opposite over adjacent, but we learned here that opposite over adjacent, tangent really works out to be sine over cosine. So there's a couple different ways that you can do these problems, but I sort of did it out the long way. We actually, back in the first part of this unit, we memorized the sine and cosine and tangent of 30, 45, and 60. So you already had this chart, but I want you to understand where the tangent of 30, where the tangent of 45, and where the tangent of 60 come from. So tangent is equal to sine over cosine. If in part A, I have the tangent of 150. So if I draw out 150 degrees, you can see them over here in quadrant 2. That does have a reference angle of 30 because the distance from this angle to the x-axis is 30 degrees. So I really want to know the tangent of 30. The tangent of 150 is equal to the tangent of 30. Tangent is sine over cosine. So sine of 30 over cosine of 30. Now you should have these memorized. The sine of 30 is 1/2, and the cosine of 30 is radical 3 over 2. When I'm dividing fractions, I change to multiplication and flip this second number. So I'm actually going to multiply by 2 over radical 3, and the 2's cancel, and I'm left with 1 over radical 3. Now I don't want to leave a radical in the denominator, so I multiply by radical 3 over radical 3, and that's really just equivalent to 1, which is why I'm allowed to do that. 1 times radical 3 is radical 3. Here's my answer down here. Radical 3 times radical 3 is radical 9, which equals 3. So I'm rationalized the denominator there. Now, the only part that you might forget is that I'm in the second quadrant and tangent is negative in the second quadrant. So my answer is negative radical 3 over 3. Now, tangent of 225. So if I draw 225 degrees, it's down here in quadrant 3. That has a reference angle of 45 because if I remember, this is 180 degrees right here. 225 minus 180 is 45. So I'm really finding the tangent of 45, and that's the sine of 45 over the cosine of 45. The sine of 45 is radical 2 over 2. The cosine of 45 is also radical 2 over 2. And when I'm dividing fractions, I change to multiplication and I flip this. So this is going to be like multiplying by 2 over radical 2. And notice the 2's will cancel, the radical 2's will cancel, and I'm just left with 1. I am in the third quadrant, and tangent is positive in the third quadrant. All students take calc. All right. And C, 2 pi over 3. So I like to work in degrees. I find it easier. So I'm just going to change that to degrees. I multiply by 180 over pi. The pi's cancel. 3 goes into 180 degrees 60 times. 2 times 60 is 120. So I'm really finding a tangent of 120 degrees, which I have drawn right here. That has a reference angle of 60 because 180 minus 120 is 60. Tangent of 60 is equal to the sine of 60 over the cosine of 60. Sine of 60 is radical 3 over 2. Cosine of 60 is 1/2. When I'm dividing with fractions, I change to multiplications and I would flip this so it would become 2 over 1. So basically you have radical 3 over 2 times 2 over 1. Those 2's cancel and I'm left with radical 3. I'm in the second quadrant though, and tangent is negative, so my answer is negative radical 3. All right, number 2, the point 0.28 and 0.96 lies on the unit circle. Which of the following is closest to the tangent of an angle drawn in standard position whose terminal ray passes through this point? Remember, tangent is sine over cosine, and sine is the y coordinate and cosine is the x coordinate. So really this is just 0.96 over 0.28, and if you put that in your calculator, you get about 3.43 if you round it off. So that was a little bit easier. Question 2. Tangent is sine over cosine, and when you have a point, cosine is the x coordinate and sine is the y coordinate. At which of the following angles is the tangent function undefined? Remember, tangent is sine over cosine, and you can never ever, a fraction is undefined when 0 is in the denominator. So basically, I'm looking to find out when cosine is equal to 0. All right, when cosine is equal to 0, the cosine is the x coordinate right here at 0, -1, and this is right here 0. So that's either an angle of 270 degrees, I go all the way around, or if I start here and I go clockwise, that's an angle of -90 degrees. So question 3 is choice 2. For an angle, it is known that the tangent is greater than 0 and the sine is less than 0. So remember, I draw my little chart here. All students take calc. Tangent is greater than 0 in the first quadrant, and it's greater than 0 in the third quadrant. And then I'm looking where sine is less than 0. Sine is positive in the first and second quadrant, and sine is negative in the third and fourth. So I'm looking for where those overlap. In quadrant 3, the tangent is greater than 0, and the sine is less than 0. Question 5 has 2 parts to it. You're just practicing 2 different ways, and I'm going to show you 2 different ways to do each part. So remember, cosine squared plus sine squared of an angle equals 1. That's one of the identities that we had. So I know the cosine. The cosine is -3/5. I'm trying to find the sine. So if I plug it into cosine squared A plus sine squared A equals 1, I already know cosine A, so that's -3/5, so I'm squaring that. I'm going to solve for sine. So sine squared A equals 1 minus -3 squared is 9, and 5 squared is 25. So basically, I'm trying to solve and get sine by itself. So it's 1 minus 9/25. 1 minus 9/25 is 16/25. Basically, I want to make this with a common denominator. So instead of writing 1, I did 25/25, and 25 minus 9 is 16/25. I'm trying to solve for sine, so I take the square root of this, and then I have to take the square root of the other side. The square root of 16/25 is 4/5. Now I'm in quadrant 2, and sine is positive, so therefore the sine is positive 4/5. So now I know the sine of A is positive 4/5. I already knew the cosine of A is -3/5. And remember, tangent is just sine over cosine. So 4/5 over -3/5. And when I'm dividing fractions, I change to multiplication and I flip this second number. And the 5's cancel, and I'm left with -4/3. Now, another way to do that is to draw it out. So basically, I was given that cosine is -3/5, and I was in quadrant 2. So I draw my triangle over here in quadrant 2. Cosine, this is the angle. Cosine is adjacent over hypotenuse. So I put the -3 here and the 5 here. You can use Pythagorean theorem to find this side right here, but you don't have to, because you should recognize by this point this is a 3, 4, 5 triangle. And then if I want to find tangent, tangent is opposite over adjacent. So it's 4 over -3. So this actually might be a little bit easier to do if you're okay drawing this out on the graph and finding it. But that's the same answer, -4/3. So if I look at B, I'll do it the long way first. Sine squared of A plus cosine squared of A equals 1. I already know sine of A is 1/3. So I'm doing the same thing. I'm going to try and solve for cosine. So I do 1 minus, and 1/3 squared is 1/9. This 1 I'm going to write as 9/9. So 9/9 minus 1/9 is 8/9. So cosine squared equals 8/9. I'm trying to get rid of the squared, so I take the square root. The square root of cosine squared A equals cosine A, and the square root of 8/9 is radical 8/3. Because the radical 8 I can't simplify, but square root of 9 I can simplify to 3. I'm in the first quadrant, so it's going to be positive. So my answer is positive square root of 8/3. Now tangent is sine over cosine. The sine was 1/3. The cosine we just figured out is radical 8/3. When I'm dividing fractions, I change to multiplication and I flip this. So this is going to be, I'm going to multiply by 3 over radical 8. The 3's cancel, and I'm left with 1 over radical 8. And then I just rationalize the denominator by multiplying by radical 8 over radical 8. And that gives me radical 8 over 8. Again, if you wanted to draw it out, I'm in the first quadrant. It's the sine is 1/3. So sine, the 1 would go here because sine is opposite, and the 3 would go here because it's hypotenuse, opposite over hypotenuse. I would then use my Pythagorean theorem to find this missing side. So when I do that, I get x squared plus 1 squared equals 3 squared. This side right here would come out to be radical 8. And then tangent is opposite over adjacent. So it would be 1 over radical 8, which leaves me right here. And I just have to rationalize that denominator. Okay, so this was just going over tangent, which we didn't talk about too much, but it was also reviewing different things that we've done throughout this chapter.